There we go. Hello and welcome back to Calculus 1. We are starting chapter 3 and we are talking about derivatives, finally. The first thing I will say is that derivatives measure the change. That's the nutshell, right? And now we're going to discover how all of that works. Again, this derivation that I'm going to do is something that honor students must know. For you guys is more to understand where this comes from. And then the problems that we are doing in this one all be limit-based. For most part, students choose to have this added to the first exam because all of the problems are taking limits. So technically, we are learning a concept for the derivative, but the calculations are all 2.3 based. So algebra and canceling and so on from 2.3, which is the reason why students usually, as a class, decide. Now you will figure out whether you want it there or not. Okay. So whatever you pick is going to be what you get. So as I already mentioned, we are introducing the derivative, and the derivative measures the change, and it is going to measure the change in a very specific way. So I'm going to derive this derivative, the derivative formula, from scratch. So consider a function of some sort. So this is your f of x on a regular xy 2D plane, and I'm going to have 2 points, point P and point Q. Now I can calculate something that is called a secant line, which is the line that connects these 2 points. In Greek, secant means to cut. And we know how to find so I'm just going to put some, I'm going to call this point A. This is going to be x over here. And what's happening is the x is going to approach A. It's going to approach A, which means that this point Q is going to start moving in this fashion, which means that these secant lines is going to start changing, right, with the equation, because every time point Q moves for whatever amount, a different slope and a different y-intercept happen. So what do I have? A point P is given as A and f of A, right? Because when you plug in the value A into a function, you get f of A as the y value. And the point Q is x f of x, clearly. Now we know that the slope m is y2 minus y1 over x2 minus x1. So in our case over here, I'm just going to rewrite this slope as f of x minus f of a divided by x minus a. So what's happening here is f of x minus f of a, those are the y values. So we know y equals f of x, right? So I'm just replacing the y notation with f of x notation. This is the same equation, just written differently. And this is from algebra. This equation is from algebra, and we just replace the function in it, but it's still algebraic equation. And observe that this is going to be valid for any blue line that you can possibly think of. But you know what's going to happen eventually? This point Q is going to collide with P, and they are going to occupy the same point in space. Now, what happens at that point?
Which point?
When Q and P become same point, what happens with our calculation? our calculation becomes impossible. Very good, because we get 0 in denominator. Once, when the x value for point P is the same as the x value for point Q, because Q got there, then you can call it a minus a or x minus x. It's the same value, and then you get 0 in denominator, which means we cannot compute. So now what happens in that case? Can we still find the line? And the answer is sure, because remember that we are able to compute infinitely many points on the way to P. We are not able to compute at P. But we don't. What kind of calculation, what kind of concept helps with that kind of calculation? The limit, right? The limit. So every single blue line, infinitely many blue lines, which are secant lines, you can compute those lines, the slopes of those lines, by using basic algebra, because P and Q have different x values. But as soon as P and Q collide into the same point, x values become the same, and then denominator is 0, and you can't compute. But you already computed infinitely many values up to that point, which is awesome. That's what limit does, right? The limit computes infinitely many values around the point of interest. Now, our point of interest is computation at P, but we can't compute it because it gives us 0 in denominator. So now, all of these blue lines are called secant lines because they stretch between two different points. The special line that goes through P, it's not equal to any of the blue lines, is going to be the limit of all of these blue lines. And the slope of that line is going to be the limit of the secant slopes. That special line is called? What's the name of the special line? Does anyone know? The red one? Tangent line. Very good. And now I'm going to say that the slope of the tangent line is equal to the limit as x goes to a of the slope of the secant line, which is limit x goes to a of f of x minus f of a divided by x minus a. So the slope of the tangent line, right, is going to be the limit of the slope of the secant line. This is your slope of the secant line. That's algebra. And we just put the limit in front. Now, this is a theoretical result. We don't use this result to compute stuff because it's very inefficient. We are going to find much more efficient way to use the limit to compute this. And then right after we're done with this section, far more efficient ways to compute derivatives. So this is more of the theoretical introductory part to the derivative. Now, guys, none of this existed in Newton's time because limit didn't exist in Newton's time. It was the derivative first, and then the integral, and then limit. Well, they talked about infinitely small value. That's how. So Newton had the right concept of it without having mathematical grounds for it. So you didn't even have the functions at that time in terms of e to the x and all that kind of stuff. It's all later, right? You figured out parabolic motion for gravity and figured out what gravity is and a bunch of physics stuff. And you say it's a birth of calculus because it is a birth of calculus with derivative and the rate of change. He didn't do integration either. So it was very, very limited at the time. So these are all formulations that happen after, in 1800s, because you have the notion of the limit, you understand what the limit is. Yes? The stream died. It's working. Apparently, it's broadcasting just fine. I have it. All right, good. All good, all good. Thank you for. Oh. All right, so what I'm going to do now is I'm going to compute one tangent line with this inefficient way, and then we're going to try to fix it to something that it's a little bit more user-friendly, let's say, for the limit calculations of the derivative. And then, starting next class, we are going to eliminate the need for limit at all for derivative calculations. So say that we want to find the tangent line. So find the tangent line for y equals x squared minus 1 at x equals to 3. So how do we do this? Well, we have the formula. Now, guys, this value 3 is your a. That's what a is. That's your a. So now we have the formula that the slope of the tangent line is the limit as x approaches, in this case, 3, of f of x minus f of 3 divided by x minus 3. And now you compute this. So what do I have? I have the limit x goes to 3, and then f of x is going to be x squared minus 1, and then we have minus, well, how much is f of 3? You can compute f of 3 on the side and get 8. Very good. 3 squared is 9, minus 1 is 8. So it's going to be x squared minus 1 minus 8 divided by, and we have x minus 3 in the denominator. Nothing we can do with that. The next step is to combine like terms. So minus 1 minus 8 is minus 9. And now we have to do, so you are doing, solving this limit is 2.3. We're not learning anything new there. What we learned new is the formula. That's the derivative formula. That, oh, sorry, the tangent line, slope of the tangent line formula. That's what we learned. And the entire calculation here with the limit is just 2.3. We see now that if you plug 3, we get 0 in denominator, so we have to use some kind of voodoo over here. What do we have to do now? Factor, very good. So that's 2.3. Yes?
Where did the x squared?
Right here.
And you plug that into f of x? Yeah.
So the whole thing is 6. So the slope is 6. Great. I'm going to improve this twice from this point on. So now we found the way to find the slope of the tangent line. Now when you have a slope and you have the point, you can go and you can find the actual equation of the line. But let's make this more efficient, because in this case now it's not too efficient. So our formula, so for instance, this derivation that I'm doing right now would be the question on the honors exam, for instance. So what I'm doing right now, which is slope of the tangent line is written as the limit x approaches a of f of x minus f of a divided by x minus a. So what I am going to do is I'm going to say, I'm going to define this, let age be x minus a. That's actually going, that substitution is going to help me a lot to make this formula easier to deal with. Because look what happens. If I am to subtract a on both sides, so I can get x minus a, which is going to be age, we are already getting an easier form because now its limit age goes to 0. X minus a on the left of the arrow is age, and a minus a 0 on the right of the arrow. The x minus a in denominator becomes age, because that's what age is. And in the numerator, we solve this, that x is equal to age plus x, right? Sorry, a plus age. That's what I want to say. A plus age. So we have f of a plus age minus f of a. Nothing we can do about that one. Now look at this. This formula is actually the formula that we want to use to compute slope of the tangent line. This is our formula. And it's much easier now because there's less work to be done. So now I want to work out the same problem, x squared minus 1 at 3, using this formula. So find the slope of the tangent line to function f of x equals x squared minus 1 at x equals to 3. Still, this 3 over here is your a. So what do we do? Well, very simple. Limit. Age goes to 0. See, you don't have to plug 3 there anymore. It's going to be always age goes to 0. And now I have f of 3 plus age minus f of 3, right, because a is 3, divided by age. This is far faster, much faster than the previous example. Now, you are going to recognize this formula from your pre-calculus class, hopefully, which is called what? Anyone?
This one?
Yeah, the formula on the bottom. Does anyone remember the name for that?
Something with box. This was step 1.
Yeah, from pre-calc 1.
I know what it is.
Yeah, different. Someone said difference. Yeah, there's one more word.
So
Difference quotient. Yep.
that's it.
Difference quotient. Difference quotient. Yep. Now, why is it called difference quotient? Let's exactly subtraction and a division, right? Difference quotient, right? It's a difference quotient. All right, good. There's a subtraction and division, right? Cool. So, so how do we compute this? Now, usually where issues happen is you don't remember function composition, and then that trips you. This over here is the function composition. Again, your pre-calc 1. We plug in 3 plus age, in this case, into f of x, and simplify. So usually that is the part that trips students, and you don't get to solve the problem very well. You all understand f of 3, but then f of 3 plus age, for some reason, freaks you out. So what do? We are supposed to plug in to our formula 3 plus age. So it is 3 plus age squared minus 1. See, instead of writing x squared minus 1, I'm replacing x with 3 plus age. And then we have minus f of 3, we said that was 8, divided by age in denominator. F of 3, clearly, right? 3 squared, 9 minus 1 is 8.
Where did the minus 1 come from?
Minus 1. 1. 1 minus 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 1 So this part over here is your f of 3 plus h, and this part over here is your f of 3. You see the function? Look. Right? F of this.
Yeah.
This is f of x, x squared minus 1. F of this will be plugged in there, squared, and you have minus 1. Look at this, x squared minus 1.
Gotcha.
X squared minus 1. So you're replacing x with the mess, put the mess there.
Gotcha.
When I teach pre-calculus, what I put a heart there, or a flower. And yeah, the first example, I just put the flower or a heart, whatever. Just run the problem with that. And then the second example, I put 3 plus h, right? So in all of mathematics, this thing over here could be a completely different problem, right? You can plug in an entire problem here and then drag that down. It's useful for computer science. Square this. So now just grind the algebra. Let's go. We have 9 plus 6h plus h squared minus 9 divided by h. These 9's annihilate each other, right? 9 minus 9 is 0. And observe that you can factor out h. That is actually the crucial part. This h always factors out. So h, 6 plus h, divided by h, and then this h cancels. How much is h? Right, so we get 6 again. We have to get 6. We're doing the same problem different way. So the only issue that I found with Calculus 1 students when you trip on this is not understanding how function composition works. Guys, copy and paste the function and replace every x with 3 plus h, 5 plus h, or whatever is that. So that's the mechanically, right, the issue. All right, cool. So we computed that. Now, what would happen if someone, once you were done with this, said, oh, I didn't need it for 3, I'm sorry, I need it for 2. What do you gotta do? Restart from scratch. You have to redo every single step. It's the same function, but now we have to use 2 plus h. Now 2 plus h is going to change when you square everything out, right? And then it's not f of 3, it's f of 2. So the entire calculation that you did before, just because you are changing from 3 to 2, has to be thrown into garbage, and you have to restart from scratch. Now, you know the procedure, right? So it's not, it's not that terrible, but still you are redoing the whole problem. So f of x is equal to x squared minus 1, and x is equal to 2, which is your a. So we are looking now for the tangent line at 2 instead of at 3. So now what does that mean? Limit h goes to 0, and now I have f of 2 plus h minus f of 2 divided by h, which is the limit, h goes to 0, of 2 plus h squared minus 1. And then when you plug in 2, that's 4 minus 1 is 3. Minus 3 divided by h. Now you have to square all of that, so it's a standard procedure from earlier. We get 4 plus 4h plus h squared minus 4, everything over h, and this is where the 4 cancels. Once the 4 cancels, we get to factor out h. It's always the same. It's just depending on what kind of function you have, and we get 4 as the answer. Oh, I'm sorry, I didn't need a 2. I needed a -7, right? from scratch, and then after 5 minutes, oh, it was not -7. I can't remember what it is. Let me look it up. Oh, it's 31. So can we actually make this very efficient? Yes. I don't want to actually go and plug in 2 and plug in 3 and plug in -7. Let me solve this for every x out there. And then whatever number you come up with, I can just use the formula I got at the end to plug things in. So to make this calculation very, very efficient, instead of writing that the m tangent is equal to the limit h goes to 0 of f of a plus h minus f of a over h, I am going to say, let me use it as m tangent is equal to the limit h goes to 0 of f of x plus h minus f of x over h. Let me solve it for every x that is in domain. And if I am able to do that, I will have a formula in terms of x, and then you tell me 2, I plug in a formula. Tell me 3, I plug in a formula. At that point, I am extremely efficient to find all of the slopes, because I took care of the general formula using this new and improved method. So instead of solving one slope at a time, I solve the problem for all of them and then keep plugging in what I need. So the same problem now. Find the tangent line at x equals to 3 for f of x equals x squared minus 1 will actually give us the formula to work with. Does anyone know what the answer should be? 2x, very good. So let's go. Limit x h goes to 0 of f of x plus h. So that's x plus h squared minus 1 minus f of x, which is just x squared minus 1 in parentheses divided by h. All I need to do is to work out the algebra there, and that will give me the answer. So limit h goes to 0 of x squared plus 2x, it's not going to fit there. X squared plus 2xh plus h squared minus 1 minus x squared and then plus 1. Divided by h. And you see that x squared dies and the 1 dies. This is your first checkpoint. Because once you're done canceling, you better make sure that only terms that have h survive, so you can factor out h and cancel. You see how the only two terms that survive both have h, so I can kick that out. And then this problematic h in denominator, which used to go to 0, is now gone. And when I plug in 0 for h in the numerator, all I get is 2x. So what's happening if a is 3? What's the slope? When a is 2, what's the slope? You remember how we did each one of them? One by one? Look at this now. This over here acts as a generator for every slope under the sun. You come up and you say, oh no, but I need -7. I just say -14. Right? You say, oh no, it's 31. Great, 62. I don't have to redo the whole procedure of the limit. I solve one limit for the entire family of these slopes, and then as you are coming up with the location where you want that slope, I'm immediately giving you what the slope is. But you will say, well, how many slopes do we have? And the answer to that is infinitely many. Because think about it. The tangent line is going to touch the function. We say it actually kiss the function, right? You have one mouth, you can kiss one location at one time. So the actual term in mathematics is kiss the function. So over here, you have a tangent line, and that tangent line has a slope. Somewhere else, you have a tangent line that has a different slope. At every point along the function, at every point there is a different slope, because this function is constantly changing in terms of x and a y. Constant function has no slope. We'll see that. It's zero everywhere because it's constant. Common sense, no change. It better be zero slope, because zero slope, it's like your desks, they're flat. You put a round object, they don't roll, because there is no slope to roll on. So your surface of the desk has a zero slope to it, and hence no change in height, hence no rolling. As soon as you introduce the slope, things start rolling, changing the height, but they don't roll on the zero slope because it's no slope. So when you connect all of those things together, but what I want to make sure you understand is that this function that we got at the end, the 2x, this function is the one that generates every single slope under the sun. You give me a point in x and I will give you what the value of the slope is. This function which we obtained through this calculation is called the derivative. So what is the derivative? Derivative is a function which you can use to calculate any slope. Mathematically, that's what it is. What does it do in terms of application? Well, what it does is it measures the change. And we'll see, obviously we'll have many sections coming up of how it measures the change. So I will say over here, this function is called the derivative. It generates all slopes or computes. Now, the notation for the derivative is f prime, because clearly this function, which is 2x, which generates slopes, is not the same as x squared minus 1, what we started with. So we have a different notation for the derivative of the function. So function has f of x, and then the derivative will have f prime. Now we are going to cover, when we venture at 3.3, we are going to talk about all different types of notation that you have for derivative. Right now, f prime is all we talk about. So I'm going to write one more time now that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. And that is the formula to compute the derivative. So derivative, in the eyes of mathematics, for the purposes of calculating stuff, the derivative is the function in which you can easily compute any slope of the tangent line. That's all it is. And now all we have is a whole bunch of different examples for you to practice algebra, right? You know the formula. You plug in the formula. You know what it means to take the limit, right? So what do we have? We have the square root, we have the square, we have all of different types of problems to find the slope of the tangent line at the end. And then you can continue these problems further, push them further to actually find the tangent line to get the exact y equal mx plus b for it. So let's see. How about a nice example for you to enjoy? Let's start simple. You will be using this formula. Again, anytime you use this formula, you're practicing 2.3. The whole chapter calculations are just 2.3. So find the derivative for f of x equals square root of x That's good enough. We don't need a point because I'm not looking for any specific. All right, so plug this in and grind.
Of the new Eli.
I don't like that. I'd rather have the percentage from the starters. I don't know why the stars strings are up.
Because you have a 50%, 100%, and the power code.
Yeah.
The stars, right? 50 and the power code.
Yeah.
So, 2 stars, right?
Yeah, like where is the calculation right? Like what if I get
Because if you go over 50, you're going to get a star.
I got confused. I was listening, I was like, wait a minute.
I play live video games.
People don't,
Just don't play Flash.
doesn't matter what it is, as long as it's a game.
Yeah, because some classes it's a known that they have program.
But if you got their power code, you'll probably have 60% to 2 stars. They pay something really good.
Now I got better like that.
I have
I left from a year and a half years. I'm not sure when I started in summer.
I had 2 months to live.
And then I started with this weirdest drink ever. And I saved it that way though. That was the only way. Last night I had a drink, it was literally the whole night. I forgot what I was done. Something like that. I mean, I wake up at like 7 or 7. I don't even need one bottle.
Next up.
Well, you're going to once you transfer. Once you transfer, that's one. Yeah, once you transfer, like whatever.
I like that they went in different directions. Left one stand on the other. Oh yeah. Well, I think they just have to go with that because you will never actually, build up quickly unless you start getting lots of probably there was a lot of meetings regarding that idea. I don't think it was just like, oh yeah, it's cool.
What do we have as the answer?
That's a lot, yes, you guys.
What do we have as the answer? You got 1? What do we have as the answer? What's the derivative of root x?
Oh, I didn't.
Problem. 1 over 2 root x. So now let's do it. What happened?
I got halfway and then.
Halfway and then that was it. You got distracted. I mean, what I could do is I'd probably put the chair right there.
I'll see if not. I plugged in square root of x, so I got square root of x plus h, and then minus square root of x.
Yeah, so we're going to have square root of x plus h minus square root of x over h. That's it, right?
Yeah, and then that's where I can.
So this is the setup.
Oh wait, do I plug in 0 then?
And you can't because h is in the denominator. So we have the square roots, we rationalize with the conjugate. So times x plus h plus root x, root x plus h plus root x. So we rationalize. Yeah, well, that's the only thing we can do when we have the fractions. Don't forget the limit. You have to write limit every single line, every single step until you get to use it up. So when we FOIL, on top we get x plus h minus x. And on denominator I'm not going to multiply because h is already factored out. And I need the factored h to eventually cancel it. So these x's will die in the numerator, and you just have h and h. So once the x's are done, the h cancels freely. So now we have the limit h goes to 0 of 1 divided by square root of x plus h plus root x. So when you send h to 0, all you have is root x plus root x. And how much is that? 2 root x. Apple plus apple is 2 apples. The limit h goes to 0, right? Limit h goes to 0, so that goes to 0, and you have root x plus root x is root 2x. All right, try function 4 over x. Four over x.
Some two the last portion.
What's the answer?
-4 over x squared plus xh.
And h is 0, so?
4 over x squared.
Negative 4 over x squared. All right. So let's take a look together. Limit h goes to 0. Now we have f of h, which means f of x plus h. So it's 4 over x plus h. Every x gets replaced by x plus h. Minus 4 over x, that's minus f of x divided by h. The only thing we can do here is find the common denominator and subtract two fractions. There is nothing else we can do in the entire problem. So we must do that. And we go with limit h goes to 0 of 4x minus 4x plus 4h. No, minus 4h.
You multiply top and the bottom by the common denominator of the two, which is x plus h times x.
Yes. So it's x plus h. Very good. So that's 4x and then negative 4x and then negative 4h.
Point that x plus h cancels because those are two denominators needed for the part.
Yeah. So these two cancel first. Now you have the double fraction. We discussed that at some point earlier. You have a double fraction, which means the ones that are far apart multiply in the numerator, which is negative 4h, and the ones that are close by multiply together, so h, x plus h. Now h and h will cancel because all we have is the division and multiplication, right? So they can cancel finally. And when you plug in h equals to 0, you are left with negative 4 in the numerator, and h going to 0, you have x times x, which is x squared. And that's the answer. So a little bit of the function composition, and the formula we are using is your good old friend from pre-calculus called the difference quotient. Since you love these fractions so much on a problem, let's do one from the textbook. This is a problem 26. And it says f of x is equal to x over x plus 1. So you can also find the tangent line, because you will have to find this. Well, let's just do the derivative. We'll deal with the tangent line soon.
Not like these.
Said no coffee. Done? Done with the answer? What is it? 1 over x plus 1 squared. All right, let's see. So we start with the limit. H goes to 0. And we have x plus h over x plus h plus 1 minus x over x plus 1 divided by h. The only thing we can do is work out the fractions. Limit h goes to 0. And now we have, when we do cross, well, the common denominator is x plus 1 times x plus h plus 1. That's the common denominator. We have over h over 1 to make it easier. And now we have to FOIL and we have to do a lot of stuff here. So it's x squared plus xh plus x plus h. And then we have minus x squared minus xh and minus x. So x squares cancel, xh and xh cancel, and x and x cancel. So all it's left is positive h. So limit h goes to 0. Two that are far apart multiply in the numerator, so that's h. And then all of these guys go on the bottom. This is where h cancels. And when h goes to 0, you have these guys multiply, so it is 1 over x plus 1 squared. Very good.
step you did? Can't you just browse out the equation?
Yeah, but it's too busy. It's too busy. All right, and we have time for one full problem to find the tangent line. So far, all of this is find the derivative, find the slope. We are going to push this one more step forward to just find the tangent line. So once you have the slope, you are able to compute, you have x, y, and the slope, you are able to compute b. So you can find the entire tangent line using this procedure. So let's see. We'll pick something from textbook again. Which problem should we do? 15 through 25, what?
18.
18 it is. So find the tangent line for f of x equals 8 minus 2x squared at point x equals 0. So find the tangent line. So you have to find the derivative first. Once you have the derivative, you'll have to plug in 0 to get the slope.
Also, use the same formula?
Yeah.
This lesson should be taught after 3.2, so like the class can just be like, look at what they used to do in this lab, and like that feel good. That
Eventually, yeah.
Calc2 is assembling in front on the bench.
So keep monitoring your email. I will send you the link for Mathematica. You should install that and play. All right, let's take a look at this problem together. So we have f prime of x will be limit h goes to 0 of 8 minus 2x plus h squared minus 8 minus 2x squared everything over h, which is limit h goes to 0 8 minus, now that's 2x squared minus 4xh minus 2h squared minus 8 plus 2x squared divided by h. 8 and 8 are gone. This one and this one are gone. And now, as I said, the checkpoint is for you to figure out that there are no terms without h. So the only two terms that are left are the ones with h, which is good. So we have limit h goes to 0. We factor out h. We don't care about anything else. So negative 4x minus 2h stays. and this is where this age dies. So we are figuring out one age because that's the only one that we have to cancel. And now when age is equal to 0, the whole thing is negative for x. So that's that. Now we have to find the slope. Slope is going to be negative 4 times x is 0. So slope is 0. Okay, now we find what's f of 0. That's the y value, right? And y value would be, where's the formula? 8 minus 2 times 0 squared, which is 8. And if the slope is 0, it's horizontal line. We have where it goes through. So the tangent line is y equals 8. That's what the tangent line is in this case. All right, so that's it for this class, and we are going to continue on Monday. Monitor for the homework. Bye, stream. Monitor for the homework, and